What's a probability that depends on something else? Ugh, I should know this. We did this for a very long time.
Probability that depends on something else.
Yeah.
Delta P?
No. Conditional probability.
Oh.
Okay. Okay, this is a real thing. Look at this. The USDA limit for salmonella contamination for chicken is 20%. That's their limit. A meat inspector reports that the chicken produced by the company exceeds the USDA limit. Okay, so now we're going to figure out what a type 1 and type 2 error would be. So write down H sub O, H sub A. Okay. The meat inspector reports that the chicken produced by the company exceeds the limit. That's what his hypothesis is, that they exceed it. So what should I write? Nope, it's not mu because it's a proportion. So P for proportion exceeds. Where should I put that one? What would exceeds be? It's not on the list.
So, reiterate it?
Mm-hmm. Which means it goes down here.
Okay.
So that means this one has to be less than or equal to. And they're both 20%. And this is the claim. Okay, so a type 1 error is when the null is true, so this one is true, but we accidentally say that it's false. So if I'm being like, let's say I work at Burger King, okay? And the truth of the matter is that we are less than or equal to 20%. But I get a weird test where they test a weird part of the counter, and it just so happens to be like extra salmonella, okay? And then that means that they say that this is true. So type 1 error is they report the company has more than 20%. And then I'm going to write incorrectly. And a type 2 error in this case would mean that this is true, but that we don't catch it. So type 2 error is they report the company has less than or equal to 20% incorrectly. I know you always want to talk about the claim with this, like you want to, but it's based on the null, not on the claim. Okay, so which one's worse? Salmonella.
Probably for this situation would be type 2.
Yes, I would say type 2 would be worse than this one. Because they're saying that the company essentially is safe, and they're wrong. So I'd say type 2 is the worst one in this one, if we're talking about public safety. If we're talking about your company being shut down unnecessarily, it'd be a type 1. But let's hope that human welfare is probably more important than a company.
So it's always based on the null?
What? It's always based on the null. I know. It feels like it should be based on whatever the claim turns out to be, but it's only based on the null. This is one of the most confusing things that I teach. Because right here, it's only about the null. The null is true. The null is false, not the claim. So in this one, type 1 error is when the null is true, but you reject it. So this is true, but we said nuh-uh. So basically, on this one, the company shuts down. And on this one, people get sick.
Why did you put a true next to H sub A then?
And, well, I also wrote true up here, and then I crossed it out when I was doing the second example. Because the second one is that H sub O is false, but they accept it. So since that one was false, I called this one true. Should we do another one? Make it easier? Okay, why don't we talk about that when we get to homework, and I'll do some of them with you. For right now, we're gonna zip through the other ones. You're gonna have to trust me on this, because it's gonna make a lot more sense in the next 2 days, but for right now, you're gonna have to trust me. All right, so there are 3 kinds of tests. Which you can probably guess are based on these. 1, 2, 3. You know, that blurry stuff? These. 1, 2, 3. Okay. So the first one is H sub O, H sub A. I'm going to use mu right now, but it really could be P as well. Mu is equal or not equal to a number. And this is called a two-tailed test. Yes, we're drawing bell curves again. Deep sigh. This one should make sense to you because it's kind of like, do you remember how I said that it was a window of acceptance? Like if I said the average amount of days this month or usually in March that are sunny is 82%. Technically, if it was 83%, I'd be wrong, but this gives you a window. Like, okay, 82% is right in the middle, and then from here to here, we'll say, yeah, you're true. But if you go too high, if all of a sudden it's 95% of the days, or all of a sudden it's 30% of the days, it can be too low or too high. That's why it's called a two-tailed test, because you can prove somebody wrong either way. And where these lines are based on how certain we are on something. Okay, the next one is less than or equal to and greater than. The tail is the alternative. This one's called a right-tailed test. And this one, it's okay to be equal to or less than, but it is not okay to be greater than. What do you think this one's called?
Left tail. Copy your own one.
So for this one, it's okay to be equal to or bigger than, but it is not okay to be less than.
Can you move it down?
Sorry.